The National Electrical Code, specifically Section 230.2e, addresses the installation of multiple services for single-family dwelling units. This section is relevant when considering running separate underground feeds from a transformer to each end of a duplex, installing a meter and disconnecting means at each location. The NEC permits this configuration provided certain conditions are met. Section 230.2e allows the use of one or more meters for a single-family dwelling unit. This implies that each unit within the duplex can have its own metering system, which is a crucial aspect of separate feeds. When multiple services are installed, a key requirement is maintaining a minimum of 3 feet between service entrance conductors at the point of entry into the building. This spacing is essential for safety and to prevent arcing or short circuits between the different service conductors. The NEC doesn't explicitly prohibit running separate feeds to each end of a duplex, as long as each feed meets the requirements for a service. This means each feed must have its own disconnecting means, overcurrent protection, and grounding system. The disconnecting means, typically a main breaker or fuse disconnect, must be readily accessible to the occupants of each unit. This allows them to energize their respective electrical systems in case of an emergency or for maintenance purposes. Overcurrent protection, such as circuit breakers or fuses, must be sized appropriately to protect the conductors from overload and short circuits. The size of the overcurrent protection is determined by the ampacity of the conductors and any connected loads. A proper grounding system is crucial for safety and to prevent electrical shock hazards. Each service must have its own grounding electrode system, which typically consists of a ground rod, ground plate, or connection to a metal water pipe. The grounding electrode system must be connected to the service equipment enclosure and the neutral conductor. When running underground feeds, it's essential to comply with all applicable NEC requirements for underground wiring. This includes using approved underground rated conductors, burying the conductors at the proper depth, and protecting them from physical damage. The specific requirements for underground wiring can be found in NEC Article 300 and Article 310. In addition to the NEC, local codes and regulations may also apply to the installation of separate underground feeds. It's important to check with the local electrical inspector to ensure compliance with all applicable requirements. On a military installation, additional requirements may be in place due to security and operational considerations. It's crucial to coordinate with the base electrical authority to ensure that the installation meets all applicable military standards. The installation of separate underground feeds can provide several benefits, including improved reliability, increased capacity, and the ability to separately meter each unit. However, it also adds complexity and cost to the electrical system. Before deciding to install separate underground feeds, it's important to carefully consider the advantages and disadvantages and to consult with a qualified electrical contractor. Here's a more detailed breakdown of the relevant NEC sections. NEC 230.2e provides the foundation for understanding the allowance of multiple services. It specifically addresses single-family dwelling units, which, in the context of a duplex, can be interpreted as each unit within the duplex being treated as a separate single-family dwelling for the purpose of service installations. The key is that each unit must function independently and have its own dedicated service equipment. NEC Article 230 covers service entrances in general. This article outlines the requirements for service conductors, service equipment, and overcurrent protection. It's important to review this article in its entirety to ensure that the installation complies with all applicable requirements. NEC 230.70a requires the service disconnecting means to be readily accessible. This means that the disconnecting means must be located in a place where it can be easily reached by the occupants of each unit. The disconnecting means must also be clearly labeled to indicate which unit it serves. NEC 230.95 covers ground fault protection of equipment. This section requires ground fault protection for services rated 1000 amps or more. If the service to each unit is rated 1000 amps or more, ground fault protection must be provided. NEC Article 250 covers grounding and bonding. This article outlines the requirements for grounding electrode systems, equipment grounding conductors, and bonding of metallic components. A proper grounding and bonding system is essential for safety and to prevent electrical shock hazards. NEC Article 300 covers wiring methods. This article outlines the general requirements for wiring installations, including underground wiring. It specifies the types of conductors that are permitted for underground use, the required burial depth, and the methods for protecting conductors from physical damage. NEC Article 310 covers conductors for general wiring. This article provides information on the ampacity of conductors, the allowable temperature ratings, and the requirements for dirtying conductors in certain conditions. The ampacity of the conductors must be sufficient to carry the load served by each unit. When planning the installation, it's important to consider the load requirements of each unit. This includes the lighting, appliances, and other electrical equipment that will be connected to the service. The service conductors and equipment must be sized appropriately to handle the anticipated load. A load calculation should be performed in accordance with NEC Article 220 to determine the minimum size of the service. In addition to the NEC requirements, it's also important to consider the utility company's requirements. The utility company may have specific requirements for the location of the meter, the type of metering equipment, and the connection to the utility grid. Coordinate with the utility company to ensure that the installation meets their requirement. When installing underground feeds, it's important to use proper trenching and backfilling techniques. The trench should be dug to the proper depth and the conductor should be installed in accordance with the manufacturer's instructions. The trench should be backfilled with suitable material to protect the conductors from physical damage. It's also important to install warning tape above the conductors to alert future excavators to the presence of underground utilities. Proper documentation is essential for any electrical installation. Keep accurate records of the wiring diagrams, load calculations, and inspection reports. This documentation will be helpful for future maintenance and troubleshooting. It's also important to label all of the service equipment clearly. Label the disconnecting means, the overcurrent protection devices, and the metering equipment to indicate which unit they serve. This will help to prevent confusion and ensure that the correct equipment is energized when necessary. Safety is paramount when working with electricity. Always energize the circuit before working on any electrical equipment. Use appropriate personal protective equipment, such as rubber gloves and safety glasses. If you're not comfortable working with electricity, hire a qualified electrical contractor to perform the installation. The decision to install separate underground feeds to a duplex requires careful consideration of the NEC requirements, local codes, utility company requirements, and the specific needs of the property. It's essential to consult with qualified professionals to ensure that the installation is safe, compliant, and meets the long-term needs of the building. Remember that the information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrical contractor or electrical engineer for specific recommendations and guidance on your project. By carefully following the NEC requirements and working with qualified professionals, it is possible to install separate underground feeds to a duplex safely and effectively. This can provide benefits such as improved reliability, increased capacity, and separate metering for each unit. However, it is important to weigh the advantages and disadvantages carefully before making a decision. Remember to prioritize safety and compliance with all applicable codes and regulations. Firstly, consider the initial investment and long-term operational costs associated with separate feeds. Secondly, analyze the potential benefits, such as enhanced reliability and individual metering capabilities. Thirdly, ensure strict adherence to NEC guidelines, especially concerning grounding, overcurrent protection, and conductor sizing. The NEC serves as the cornerstone for safe and compliant electrical installations. Its guidelines are developed and updated regularly to reflect the latest industry best practices and safety standards. Therefore, a thorough understanding of the NEC is crucial for anyone involved in electrical work. For instance, NEC Section 230.2 discusses the general requirements for services. This section states that a building or structure shall be supplied by only one service unless specifically permitted otherwise in 230.2b3. The exceptions listed in 230.2b3 outline specific scenarios where multiple services are allowed, such as for fire pumps, emergency systems, and large capacity installations. NEC Section 250 provides detailed requirements for grounding and bonding. A proper grounding system is essential for protecting against electrical shock hazards and ensuring the proper operation of electrical equipment. The grounding electrode system must be installed in accordance with NEC 250.50 through 250.70. NEC Section 300 covers wiring methods and materials. This section outlines the general requirements for wiring installations, including the types of wiring methods that are permitted, the installation of raceways and cables, and the protection of conductors from physical damage. NEC Section 310 provides information on conductors for general wiring. This section includes tables that list the ampacity of conductors, the allowable temperature ratings, and the requirements for derriting conductors in certain conditions. The ampacity of the conductors must be sufficient to carry the load served by the unit. NEC Section 408 covers switchboards, switchgear, and panel boards. These components are used to distribute power throughout the building. The switchboards, switchgear, and panel boards must be installed in accordance with NEC 408.30 through 408.70. NEC Section 430 covers motors, motor circuits, and controllers. If the duplex includes any motors, such as those used for air conditioning or appliances, the motor circuits and controllers must be installed in accordance with NEC 430. In addition to these specific NEC sections, it's also important to be familiar with the general requirements for electrical installations, such as those found in NEC Article 110. Article 110 covers topics such as workmanship, equipment approval, and access to electrical equipment. The NEC is a comprehensive document that covers a wide range of electrical topics. It's essential to stay up to date on the latest edition of the NEC and to consult with qualified professionals when planning and installing electrical systems. Proper planning and design are crucial for a successful electrical installation. Before beginning any work, it's important to develop a detailed plan that includes the following elements. Firstly, a load calculation to determine the total electrical demand of each unit. Secondly, a wiring diagram showing the layout of the circuits and the location of the electrical equipment. Thirdly, a grounding and bonding plan to ensure that the electrical system is properly grounded. Fourthly, a plan for protecting the conductors from physical damage. Fifthly, a plan for labeling the electrical equipment. Once the plan is complete, it's important to obtain all necessary permits and approvals from the local authorities. This may include submitting the plans for review and inspection. During the installation, it's important to follow the NEC requirements and the manufacturer's instructions. Use approved materials and equipment. Ensure that all connections are made properly. Protect the conductors from physical damage. Label the electrical equipment clearly. After the installation is complete, it's important to have the work inspected by a qualified electrical inspector. The inspector will verify that the installation complies with the NEC requirements and that it is safe to energize. If the installation passes the inspection, the inspector will issue a certificate of approval. This certificate is required before the utility company will connect the power. Regular maintenance is essential for keeping the electrical system in good working order. Inspect the electrical equipment periodically for signs of wear and tear. Replace any worn or damaged parts. Keep the electrical equipment clean and free of debris. Schedule a professional inspection of the electrical system every few years. This will help to identify any potential problems before they become serious. In addition to these general maintenance practices, it's also important to be aware of the specific maintenance requirements for the different types of electrical equipment. For example, circuit breakers should be tested periodically to ensure that they are functioning properly. Ground fault circuit interrupters, also known as GFCIs, should be tested monthly. Surge protectors should be inspected regularly for signs of damage. Proper maintenance can help to extend the life of the electrical system and prevent costly repairs. It can also help to improve safety and reduce the risk of electrical hazards. If you are not comfortable performing electrical maintenance, hire a qualified electrical contractor to do it for you. They can perform a thorough inspection of the electrical system and identify any potential problems. They can also perform any necessary repairs or replacements. Electrical safety is paramount. Always take precautions to protect yourself from electrical shock. To energize the circuit before working on any electrical equipment, use appropriate personal protective equipment such as rubber gloves and safety glasses. Never work on electrical equipment when you're wet or standing in water. Be aware of the hazards of electricity and take steps to avoid them. If you are not sure how to safely perform an electrical task, hire a qualified electrical contractor to do it for you. Electrical work can be dangerous if it's not done properly. Always prioritize safety and follow the NEC requirements and the manufacturer's instructions. By taking these precautions, you can help to prevent electrical accidents and injuries. Remember, electricity is a powerful force that can be dangerous if it's not handled properly. Always respect electricity and take steps to protect yourself and others from its hazards. The NEC is a valuable resource that can help you to understand and comply with electrical safety standards. Stay up to date on the latest edition of the NEC and consult with qualified professionals when planning and installing electrical systems.